Hello everybody, I'm doing Leetcode just like every day. By the way, I was watching yesterday's video. It's so bad. I look so tired. Like I look like I haven't had proper sleep. Yeah. So in this video, I will try to be, I don't know, more active. I don't know. I didn't like that video. And the better part of the video is mute, because I forgot to turn the mic back on. I have to like turn it off time to time whenever there is now noise in the background. And yes, I forgot to turn back on. So yeah, the last majority of the last portion is mute. I'm just saying things, and yeah, I think it's for good. Okay, sliding window maximum. Just make sure I'm recording. Yeah. This is my second attempt. After first attempt, I learned that we need to use a deque in this problem. A deque is basically a queue, but we can do operations on both ends. We are given an array of integers nums. There is a sliding window of size k, so the size is already given here, which is moving from left of the array to the right. You can only see the k numbers in the window. Each time the sliding window moves right by one position. So this is the window, and we have to find what do you have? We have here. Return the max, like we have to find the max value in every sliding window, in every window. So in this window, the maximum, the largest element is number is 3. So there you go. We have 3. Window slides to the right. What is the new max? What is the largest element in this window? It's 3 again. What is the largest element number in this window? It's 5. And so just like this. The way to do this, actually to use a deque, is well, first of all, we are going to need deque. We will be adding okay, the main idea is that every time there is a new element, we check if that element is greater than whatever we have at the top, and my queue's top will always have the largest number. So if my new number is greater than the largest number I have seen so far, it's in my queue, then I am going to update my queues front. Basically, now this is the value that I need. This is the new largest number I have found, and drop all the previous largest numbers. Well, no, actually, not, because here's one more thing. In my queue, I'm not going to maintain extra elements. So if I know 3 is the largest number in the window, I don't need to keep 1 and -1 in the queue. So I will just drop them. And the way that's gonna happen is well, like I said, we can do operations on deque on both ends. So if, for example, if this is my queue, and one comes in, it's just gonna go into the queue. It's empty because that's why one comes, and then 3 next element, and then the 3. Okay, now 3 is greater than my queue's front, which is 1. So what I'm gonna do is I'm gonna start no. Well, I should start removing elements from the okay. Well, if I start removing elements from behind, what does mean? What's that? From right side. Like how would I, what's the name of the version? Back pop or something? Uh, okay, so 4 steps. There are 4 steps to this. This was the first step. Okay, let's proceed. Array deque of int, type int, and for I starting from 0 till nums last index minus k plus 1. Okay, and initially my queue is gonna be empty, and by the way I'm gonna be pushing the indexes instead of the actual numbers. And this is a monotonic queue. What does that mean? It means the numbers are stored in a certain order, either increasing or decreasing. Okay. If my deque is empty, well, if it's not empty, and okay, for my result is my mutable list of integers. What I can do is I can have the value of the initial window recalculated and then subtract, or I can say when should I when is the right time to start adding elements to my result list? Result dot add result dot add deque front, pole front or front, we'll worry about that later. So when my window is of size 3, I minus k 0 minus 3 and then 1, yeah, when my window size, this is my window size, when this becomes k, then we basically start adding elements in the in my result array. Now for the next part, I also need to check if this current element is greater than whatever I have in my queue. Actually, I should use while loop. As long as this current element is greater than deque dot front, right? I'll keep popping off elements, polling off, pole back or something. Back pole. I don't know. I haven't used this API or data structure in Kotlin, so I'll have to ask ChatGPT after this. And also, it's good. Let's check. Let's check queue being empty. Now, and I think after that, it's a good idea to queue dot add this index I. So we are actually using indexes, so this is what we need. Lastly, this is a two-step algorithm, and last step is we need to remove those extra elements from the queue as soon as my window moves by one position. Actually, let's first try to visualize. So I have one queue, let's add this, and then I have 3. Now, so my window is still hasn't reached the size. Is this 3 greater than this one? Yes. Okay, then what we want to do is we want to remove this one, and yes, add 3, index of 3. Okay, and then next element is -1. Now 3 is already present. -1. -1, we just add index -1. Okay, and I think at this point my window has become the size of k. So whatever is at the front, I add that to my main list. 3. Should I remove 3 from the queue now? No, I don't. I should not. Well, next element, it's -3, -3, -3. Well, we have 3, we have -1, and now -3 is not greater than anything in the queue, so we just add it to the queue. Now if my queue size, if my deque size exceeds k, then that means I need to no, actually no. I should work according to this window. If my what number to drop from this window? So it's -3. Okay, next number, 5. Okay, let's see where 5 goes. 5 is greater than 3, so we start removing elements from back. We remove -3, -1, and 3, and finally we have 5. And of course, in this window, 3 is still the largest, so my result will have 3, 3. Now 5. 5 got added later. Okay. Maybe we have a problem here. Maybe, yeah, we have a problem here. 5 got added later. Maybe I need. What is the index of? What is the I at this point? 0, 1, 2, 3, 4. 4 minus 3 is 1. So I also need to increase. Let's extract it to make a new variable. Size I minus k plus 1. Size or window size. Window size, and we'll increase this window size. in every iteration. Okay, well, this part is I have a feeling that my mic is a little far. What number to drop? What number to drop when my window slides? Well, let's think about it. My queue's front will always have the largest number. But if that largest number, when the window slides, if that number is not in the window anymore, so the pushback. If 5 got added at this step, 5 got added, the queue was basically empty. No, actually 3 was at the front. Yes, 3 was at the front. Then we emptied the queue and then 5 got added. And then, okay, the window slides. Here, we only have 5 in the queue, and now there is a 3, which is not greater than 5. 5 is still the maximum. And then we have 6. 6 is greater than 5. So my queue is empty again. And now 6 is the only element. And then 7. And my queue is empty again. And now 7 is the only one. Do I need to worry about removing the characters from the queue? Because, well, at least for this example, I never had to worry about that. Let me look the Kotlin deque API. deque add all, add first, prepends these, add last. Yeah, we need add last. Add last. First returns the first element or throws if empty. Get is empty, iterator last. All remove first, remove at, remove last. Yeah, remove last, remove last. add last, and first I think that's all. Let's see. And at the end, I am going to return this array, return this list actually, but to type array maybe. Array. Looks like mutable list of okay. We have an infinite loop. No. Reassign. Well, can't I do this? Okay. Okay. How to do that? It's like mutable list. How to convert mutable list into Kotlin int array. Kotlin array, but your function is this. Yes, do int array. It's a very nice function here. Okay. Value of I unresolved. Size of window. Oh, it's gonna start from 0. 0 minus Boolean was expected. Line and window size. I minus k. No, this is not right. This is not right. What am I trying to do? I want to check. I want to check size of my window. So 0, 1, and 2. So 2 minus k, which is 3, 2 minus 1 plus 1 is 0. It will stay 0. But no, it will not stay. Well, I can simply say that if my I is greater than when my I is greater than 0, this element, and then 1, yes, 1 and 2, 1 and 2, then 1, 2, 3, all these, and then 4, which was greater than all of these. Okay, Q is working fine. I'm just not able to get it get this to it. And also I need Q I minus plus 1. What does this mean? What does this mean? Well, my I is going to be like this, minus k w. What is w at the 0, 3, 3, 3, and I'm also saying plus 1 plus 1 plus 1. So that means I'm just saying at this point it's -2, -1, and 0. So maybe 3, 3, and then one more 3. No, no. We don't. 1. We actually have 5. What if I say greater than 0? Okay. Now the problem is the loop is not running till the end. Now the problem is we have missed last element. And now the problem is we have got index out of bound. Okay, this was right. Maybe 6 was the last index. 0, 1, 2, 3, 4, 5, 6. Whoa, what happened? I mean, I'm pretty sure I have that 7 looped here. I mean, the 7, it got looped on last. Yeah, 7 was present. And the last. So can I don't know, do this in a very dirty way, like if my deque is, if it's not empty, then result dot add whatever is at the front first. Maybe it will not work. I have a feeling it will not work. Yes. K was 1. K is 1. But okay. That is my just I went out to get some fresh air. Okay. 0, 1. Yeah, same problem. We are keeping the redundant numbers in the deque. Need to remove them as soon as Windows slides. Need to remove the redundant numbers. Where are they at? In this case, the size of the window is 1. If the size of the window is 1, then we can just return the input array. See, if k is equal to 1, we return the nums. That was another dirty hack. Yeah. See, we did not make very long, very far. Yeah. So the algorithm doesn't work. With that algorithm, you can't make very far. It'll catch up with you. This was 7, 2. So we have 7, and then we have 2, and then this window 1, 2. Based on the index, this is monotonic queue. This is monotonic queue. 0. Hang on. If my well, I need to check the index, right? If deque dot front, which is an index, is smaller than my left index of the window, what is the index of my starting index of the window? What is the starting index of the window? Size of the window is 2. Here it's 0 and here it's 1. So what I marks the starting of the window. I is the starting index of the window, right? Yes, that's right. And if I is greater than, just a sec. Zero, 1. If my top index is smaller than I, then that means this thing has become redundant. It has not part of the window anymore. So deque dot remove front. This case there's an error, right? Remove front. Remove last. Remove last. Wait, I can't remove from front. First. Remove first. Remove first. Remove first. How do I know that the first element first? Remove first. What am I doing? First. Okay, it's good time to look at the solution. Monotonic Q. Iterate over the array with the right pointer. For each element, remove all smaller elements from the back of the deque. They can never be maximum again. At the current index, compute the left boundary. Right minus k plus 1. I think this is the part we missed. If the maximum is out of window, remove it. All right, yeah, of course, because we only care about the maximums. Right, that's why we need to remove it from the front. If a minimum element, if some small number is at the front, well, first of all, it cannot be at the front. If there is some small number in the queue, we know that it's not going to be added to the result array. Okay. Once the first full window is formed, write greater than. Okay. deque last. Right is greater than k minus 1. K minus 1. Alright. Yeah, sure. K minus 1. Well, I is greater than k minus 1 because it's 0 index. Yes, yes, yes. So I don't need a w. While deque is not empty and my current number is greater than. Okay, we are checking the first, and here this is checking the last. But remove last, and then we are adding last. Small or equal than k minus 1. I minus k. I wonder why is this checking last element. Last. Should be checking the front. Because if this number at front actually represents the largest number. Let's try to change this. Okay. last. Okay, but I still have my question is why are we checking nums I with should not be checking num I with nums deque first, because number at the front is the largest one in the deque. In decreasing order of their values. Front has the largest, back has the smallest. We remove all smaller elements from the back because they can never become maximum in any future window. Since 5 is bigger than all. Okay. Well, that kind of makes sense. Because even if the current number is not large, it's not greater than whatever we have at the front, we still need we are still gaining this, you know. Okay, yeah, makes sense. We get the benefit of getting rid of all the smaller numbers. And if front number is smaller than current one, it also gets removed. Okay. Because the front is the current maximum, if you did this, you would wrongly remove the current max, which breaks the structure. It comes. This is the window, this is the deque, correct behavior. Remove 6, remove 7, keep 9, and add 8. If we compare it directly with first, well, 8 is not greater than 9, you would keep, which breaks the decreasing order. Alright. Move from the back. Okay. We should have result after the window forms. Oh yeah, is that why it's not picking up the last element, the last number? Yes. Yeah. I need to shift this. Where, here or at the end? The end. No. So we are here. Oh yeah, it is greater than or equal to. Okay. No. Mm, mm, oh, I didn't notice this solution has two while loops. Not empty and alright. This one is not empty and first. Okay, maybe my this condition is already doing what this while loop might be doing here. Then I add, and then well, my I is greater than or equal to this. I add, it should work. It just did. Why it's not working now? What's gone wrong? Because of this condition. Is that really why? No, I have messed up something. I think I have. Wait, no. Yeah, I think I messed up something. I know it's a very like tiny mistake somewhere. Okay, I'll fix that. It'll just take so much time to find it now. Um, should add result after window forms. Okay. Okay. I'm fine. Done basically. Yeah, that was the video. Thanks for watching this video. I hope I was a little energetic. That I hope I did not look like I need sleep. Okay. Okay. Thanks for watching this video, guys, and I'll see you next time.